In this video, we'll discuss the values of a ratio through unit rates and multipliers. Now, one of the questions that's often asked is, why does cross multiplication work when you set up a proportion? For example, if we look at this problem, 8/5 equals a over 7. We know that we're going to take and multiply our denominators diagonally on both sides, and that we would end up with 8 times 7 equals a times 5. So the question is, why? Well, what we're really doing is creating a common denominator. So we say, well, what is the common denominator of 5 and 7? So we say 5 times 7, well, that would be 35. So if I take and make a common denominator on my left fraction or my left ratio, and I do the same thing, create the common denominator with my right ratio, I'll see that what I end up with is the 8 times 7 over 5 times 7, and equals a times 5 over 7 times 5, which puts both of those numerators over 35. And because I have a common denominator, I know that for this to be an equivalent statement, my numerators have to be equivalent. So I end up looking really at 8 times 7 equals a times 5, or, which is the same thing that I get when I cross multiply. So that's why cross multiplication works. Now, other things that are important to understand is, how do we connect the idea of a ratio to the fraction, and how does that relate? And what it really creates is what we call a unit rate. And that's when we have a ratio of a to b, the first quantity to the second quantity. We know that the fraction of a over b really tells us how many units of the first quantity there are for one unit of that second quantity. So say that I have 3 teaspoons of salt for 4 teaspoons of pepper. I can look at this two different ways depending on what I'm trying to do. So the first one would say that I'm looking at 3 teaspoons of salt to 4 teaspoons of pepper. The fraction that relates to, we would say, is the first to the second, so 3 over 4. That means really that I have 3/4 a teaspoon of salt for every teaspoon of pepper. Now the other way I could look at this is I could be looking at 4 teaspoons of pepper to 3 teaspoons of salt. It is, the two parts are still there, and what I see though is that when I convert this the other way, that gives me a fraction of 4/3, because now I'm looking at 4/3 a teaspoon of pepper for every teaspoon of salt. So the question then is, well, why do I care about being able to go both ways? And a lot of that depends on the problem that I have. So say that I have this problem here. I add 3 teaspoons of salt for 4 teaspoons of pepper. I added 10 teaspoons of pepper, say, to any given recipe. How much salt should I add? So let's think about it visually and see, well, why does it matter which way I go with my unit rate? So first thing, I can literally draw out using the strip diagram. Here I've got 3 units of salt, 4 units of pepper. Well, if I want to change this to the idea of a fraction, what I know is I want to say here that maybe that one group is created by what it takes to make the pepper, which is 4 pieces. If I know that this represents one group, I can then compare that to my salt and say, well, how many pieces does my salt have? Well, it only has 3 pieces out of the 4 it takes to make a group. So this would be 3/4 of a group. So then I would say then, if I wanted to see, well, what does that help me with? That tells me that if I have 3/4 of a group times however many groups of that 1 teaspoon of pepper I have, that will give me the amount of salt I need. Conversely, say I look at it the other way. I've got my salt and my pepper still, but maybe I say instead that my salt creates one group. So there's my one group. Then I'd say, well, what does that mean about my pepper? That means that I have 4/3 of a group, because I've got one full group and this extra 1/3. That tells me that if I know how many groups of that salt I have, of the 1 teaspoon of salt, and I multiply that by the 4/3, that will tell me how much pepper I have. So depending on what I need to know from the problem, what I'm trying to solve for, could tell me which of these two interpretations is the one I need to use to help me. So here I'm trying to find out how much salt should I add. So I know how many groups of 1 teaspoon I have in this problem. So I have 10 of those groups. So I'd be looking at the first interpretation. So I know that the salt, it's always 3/4 to every group of, or 1 teaspoon of pepper that I have. So I have 10 groups, so 3/4 times 10 will give me 30/4. Or if I simplify that, that'd be 7.5 teaspoons of salt. Let's look at another problem just to help out. Say I want to make a special shade of green to paint our living room, and it uses 5 cups of yellow for every 2 cups of blue. And I have 12 cups of yellow paint. How much blue should I add? So let's set it up again the same way. I have my 5 cups of yellow and 2 cups of blue. Now, if I make my one group be represented by the blue, I know that means that my yellow, I have 5 halves groups, or 2.5 groups, because here's a group, and here's half of a group. That would mean that if I want to figure out how much yellow I need to use, I'd take that 5 halves and multiply it by how many groups of 1 cup I have of the blue. Conversely, say I want to look at it the other way and say that my yellow is my 1 group. That would mean that since it takes 5 parts to make that 1 group, my blue represents only 2/5 of a group because I only got 2 parts of the 5 it takes to make that 1 group. So here it would be the 2/5 times however many groups of that yellow I have. And that tells me how much blue I need. So here I'm trying to say, well, how much blue should I add? Well, if I want to find blue, that would mean I'd actually want to use the second statement, the second image here to help me out. So I know that I get 2/5 of a group of blue for every group of yellow I have. So I have 12 groups of that 1 cup of yellow. So 2/5 times 12 would give me the 24/5, or 4 4/5 cups of blue paint.